Hello friends, my name is Chinmay Deshpande and in this video lecture we are going to discuss about types of DC motor. Now the first is nothing but separately excited DC motor. What is the meaning of separately excited DC motor? Now as the name suggests, the field coils or the field windings are energized by a separate DC source as shown in the figure. Now here you will observe this is what is a field winding. To that field winding the separate DC supply is given. Because of that, the current which will flow is nothing but IF, that is a field current. After that, this will be armature. Now in the armature, it will produce a back EMF which is EB. RA is the armature resistance. IA is nothing but a armature current, and this is what is the voltage V generated. So from this diagram, you will be able to understand that to the field winding, this DC supply is given separately. So therefore, this motor is called as separately excited DC motor. Second is nothing but self-excited motor or self-excited DC motor. Now again, as the name suggests or name implies, the self-excited is nothing but what? In this type of the motor, the current in the winding is supplied by the machine or a motor itself. Now there are three types of a self-excited DC motor. First is shunt wound or a shunt motor. Second one is series wound or a series motor. Third one is compound wound or compound motor. Now let's discuss first self-excited DC motor, that is shunt wound or shunt motor. Now what is a shunt wound motor? This is the most common type of a DC motor that we can use in our day-to-day life. Here whatever field winding is, that field winding is connected in a parallel with the armature. So this is what is a figure. Here you will observe that. This is what is a source. Then here if you observe, this is a wire which is to be taken on the pole. Then it is connected in series with this, and again the another end is connected to this side. Now this is what is armature. It has a commutator, and this is what is nothing but a shunt field. Now if you draw, this is a diagram, but if you draw it schematic, then you will get this will be field winding and this will be armature. So as the name suggests, shunt wound, what you observe here, whatever field winding is there, this is a field winding, and whatever armature, it is connected in parallel with each other. So this is what is a diagram that we are going to use here for understanding shunt wound or shunt type of a motor. So this will be armature. Now whatever current which will be is nothing but IT equal to IA plus IF. Now here IT is nothing but a total current. IA is nothing but the part of the current will flow through the armature, that is armature current IA, and part of the current will flow through shunt connected field winding. So this will be current flowing through a field winding. Now let's discuss in detail equations associated with it. The current, voltage and the power equations for a shunt motor can be written as. Now by applying KCL at this junction, what you will get is nothing but IT equal to IA, part of the current which will flow through armature, and IF, that is part of the current which will flow through a field. Where this I, or sometimes here we can use I also or IT also. This IT is the input line current, total current. IA is the armature current, and IF, or one can write it as ISH also. This is what is a shunt field current. Now here IT equal to IA plus IF, this is your equation number 1. The voltage equations can be written by using Kirchhoff's voltage law for a field winding. Let's say this will be field winding. So it has its own resistance is equal to RSH. Current which will flow through this is nothing but IF. So therefore the voltage across this shunt field winding is nothing but V equal to ISH into RSH. And similarly for this armature winding, we can write the equation as V equal to EB plus IARA, where EB is nothing but the back EMF which is produced. Now here, what is the power equation? Now we know that power input equal to mechanical power plus losses associated with armature and but obvious losses with a field winding. So therefore one can write power input is nothing but V into I. Now mechanical power developed is nothing but PM. Losses in the armature, if you observe, armature has a current IA and it has its resistance, armature resistance R. So we know that loss is I square R. So it will be IA square into RA plus losses in the field. Now here again you will observe RSH is the resistance of the field winding. IF or ISH is nothing but current which will flow through a shunt field. So therefore it is ISH square into RSH. Treat this equation as equation number 2. Now, what was the equation number 2? Here, V equal to ISH into RSH. So therefore, we can write from this equation, RSH equal to what? V upon ISH. Now, put this value RSH equal to V upon ISH. So what you will get? Left hand side VI will be as it is, PM will be as it is, IA square into RA will be as it is. Now, in place of RSH, we have to put V upon ISH. So after putting that, one ISH from numerator and denominator ISH will cancel out with each other. So therefore we will get VI equal to PM plus IA square RA plus V into ISH. So therefore now I can write this equation for a mechanical power PM. So what you have to do? Just shift all these terms to left hand side. So we will get VI minus IA square RA minus V into ISH. So now here if you observe, from this term V into I and from this term V into ISH, I can take V as a common. So PM equal to V into bracket 1 minus ISH, sorry, I minus ISH minus IA square into RA. This is the equation. But what is the equation number 1? We got this equation, total current I equal to armature current IA, this is armature current, and field current IA. So therefore, from this, or in other words, we can write it like this also, I equal to IA plus ISH. I already told you that in some books it will be IF, that is a field current, and in some books it will be ISH. So here we are going to use ISH. Now from this equation, what we can write? We can write it as IA equal to I minus ISH. Just we have shift this term ISH towards left hand side. So in place of this I minus ISH, we can put here IA. So our equation for PM will be PM equal to V. In place of I minus ISH, I have put here armature current IA minus this rest term, that is IA square into RA will be as it is. Now again, from this term, what we will do? We will take IA as a common. So therefore it will be PM equal to IA into bracket V minus IA into RA. So this is the equation for mechanical power. Now here from equation number 3, we know that what is the voltage here? V equal to voltage across armature, V equal to EB plus IA into RA. So now suppose if I shift this IA into RA term towards left hand side, then I will get expression for EB, that is back EMF. So EB equal to V minus IARA. Now in place of this V minus IARA, I can put here EB. So therefore we will get PM equal to IA into EB. This is the expression for a mechanical power. Now multiply this equation number 3 by IA, then what we will get is V equal to, this is equation number 3, V equal to EB plus IA into RA. So we will get by multiplying IA on both sides, V into IA equal to EB into IA plus IA square into RA. So therefore, V into IA equal to, this EB into IA is nothing but a mechanical power. So this will be PM plus IA square into RA. Where this V into IA is nothing but electrical power which will be supplied to the armature of a motor. So this is about shunt wound or the shunt motor. Now, the next type of the motor is nothing but series wound or the series motor. Now, as the name suggests, what is a series wound? Here, the field winding is connected in series with the armature. So this is what is a diagrammatic representation. This is a field winding. Here you will observe that it is connected in series with this armature, and again it is written to this particular point. So therefore, now this will be field winding, this will be armature. So how it looks like? It looks like this. Now for understanding of a series wound motor, we are going to use this diagram. So here what you will observe, the total current or the current equal to current which will flow through field winding, that is series field winding, and current flows through armature, that is IT equal to IA equal to IF. Now let's discuss here the equations associated with it. Here you will observe that total current I equal to IA plus or IA equal to IF, because it is a series wound motor. Now here what I is the input line current, IA is the current which flows through armature, and IF, or here one can write ISE also. It is nothing but current which flows through a series field. Now, now here for the basic voltage equation is nothing but V equal to EB plus IA into RA plus ISE into RSE, where that EB is nothing but a back EMF, then RSE is nothing but resistance of series connected field winding, and RA is nothing but resistance of a armature winding. So as we know that total current I equal to current flowing through armature equal to current flowing through series field winding. So therefore this equation 2 we can modify it as V equal to EB plus I into bracket RA plus RSE. So treat this equation as equation number 3. Now suppose if I want to find out a power equation, then we have to multiply this equation number 3 by a current I. So what we will get? V into I equal to I into EB plus I square into RA plus RSE. That is, power input, it will be resolved into 3 components. Mechanical power which is developed, that is I into EB, plus losses in the armature and losses in the field. So therefore what we will get? V into I equal to, this I into EB is treated as a mechanical power, that is PM, plus I square into bracket RA plus RSE is nothing but losses associated with armature and the field winding. Thank you.